Hi guys, I am Prachi Agarwal from Pranveer Singh Institute of Technology. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week we'll post CodeChef problem explanations, conceptual videos on various programming patterns and also conduct live problem solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great. Now that you have subscribed, let's get started. So today we'll be solving the problem bulbs and wires, which is a very interesting problem and it is an easy level problem which came in the September Cook Off. So now let us see the agenda for today. First, we will understand the problem statement and the concept by which we can solve the problem. We will discuss the observations and the steps required to solve the problem. And then we'll do a quick walkthrough of the code, though you should try the code on your own. So before we rush to the problem statement, let me share some great news with you. CodeChef, in association with Unacademy, has started with live competitive programming classes that will be taken by top experts. So if you are one who enjoys programming and wants to learn more about coding from the top experts, then you can use my referral code that is given in the description box below and subscribe to these classes. So in the problem statement, we have n bulbs and all these n bulbs are connected through wires. And initially the state of all these bulbs is off. So here, as you can see that these are the n bulbs and I have connected them through wires. Then 0 means an off state of the bulb. Now we are given a state S. This is a state S and it is a sequence of on and off bulbs. So 1 means an on bulb and 0 means an off bulb. So this state is a sequence of on and off bulbs. Now what we need to do that we need to reach this state from the initial state of the bulb. And in order to do that, what are the steps that we can perform? So first thing is that we can switch on some of the bulbs. But since this is a series connection, the bulbs are connected in series through wires. So if we switch on even one bulb, suppose I switched on the first bulb, then all the bulbs connected to it will be switched on. So you will say that only the second bulb is connected to the first bulb through this wire. But this is a series connection. So any bulb that is connected to the first bulb directly or indirectly will also be switched on. So if I switch on the first bulb, then all of these n bulbs will be switched on. But we don't need that in this state. As you can see that the state is a sequence of both on and off bulbs. So that is why we are given the facility that we can cut some of the wires. So we can cut at most k wires in order to reach this state of the bulb. So now suppose initially if I cut this first wire, and then I also cut this wire after the fourth bulb. So I'll cut these two wires. Then this group of bulbs, as you can see, will remain off. Why? Because we have already cut these wires. Now if we switch on the first bulb and the fifth bulb, now if we switch on these two bulbs, then they cannot affect these three bulbs that are present in between. So this is one group of bulbs that will never be able to switch on because we have cut the wires on both ends. So what are we exactly doing is that we are segregating the group of bulbs. That is, in this state, if we need a set of bulbs that should be off, then we will separate these bulbs. Like here we have 3 bulbs here and then 2 bulbs here. And for these, we will have to cut the wire in the initial state. We will have to cut both ends of the wire from this group. And similarly for this group also, we'll have to cut the wire on both ends. But it may still be possible that we are not able to achieve the state S by cutting the wires. Because as you can see that we are allowed to cut only K wires, but it might be possible that we need to cut more than K wires in the state that we need to achieve. So in order to do that, we are given one more step that we can follow, and that is, look at the third step. It is written that we can disconnect some of the bulbs from the electrical network. So what does that mean? That suppose we want the first bulb to be off, and we don't want to affect any other bulb. So we will just disconnect this bulb. Disconnecting this bulb will change its state to 0 or off state. But even if it is connected in series to any other bulb which was on, then it will not affect that bulb. So suppose the first bulb was connected in series to some other bulb that was already on. So now even if we disconnect the first bulb, it will not affect this bulb which has been added. So that is the advantage of disconnecting the bulbs, and we will definitely be able to reach our state that we need to achieve. Now, what we need to do in the question is that we need to minimize the number of bulbs that you need to disconnect in order to reach the given final state. So basically, we are performing all these minimizing the number of bulbs to disconnect and cutting the wire. Why are we doing this? Because we need to keep a certain group of bulbs in the off state. So minimizing the number of bulbs to disconnect, it also means that we will need to maximize the number of bulbs to keep them off by cutting the wire, because as you remember in the question, it is given that we can cut at most K wires to keep those group of bulbs off. So now if we maximize these number of bulbs that we are able to keep off by cutting the wires, then automatically we can minimize the number of bulbs that we'll need to disconnect. And what will be our answer? So if we count the total number of bulbs that are in the off state, that is in the given state, in the given final state, the total number of bulbs that are in the off state minus the maximum number of bulbs that we can keep off by cutting the wires. So this will give us our answer. That is the minimum number of bulbs that we need to disconnect. So I hope you got my point. Now let us take an example to understand the question better. So now in this example, consider this state that we need to achieve from the initial state. So initially all the bulbs were off. Now we need to achieve this state. Now, as I explained earlier, that why do we need these wire cuts? We need wire cuts to keep a certain group of bulbs off. Like suppose this is a group which has 5 bulbs which are in the off state, and we need to keep these bulbs off in the final state. So then we will require 2 wire cuts for such kind of bulbs. One from this side and one from this side, so that it is not affected by any other bulb which is on. Similarly, these kind of groups of 0 bulbs, they will be present in the between. So here we have one bulb. This will be counted as a separate group. Then here we have 7 bulbs. So this is also one group which will require 2 wire cuts in order to keep them off. Now there can also be a second possibility where we'll require just 1 wire cut, and those will be for the group of zeros that are present either at the beginning or at the end. So now here, as you can see, in the beginning, these group of zeros can only be affected by one bulb which is on, that is only on the one side. So that is why for this these kind of groups we'll require just 1 wire cut. And here also in the end, so this group is also getting affected only by 1 bulb on this side. So this is the bulb that can switch this group of bulbs on. So that is why for these kind of groups also we'll require just 1 wire cut. So basically there are 2 types of zero groups that we need to determine. First one is that which will require two wire cut that will be present in the between. So it is 7, 5 and 1. And the second type of group is which will require one wire cut. So which are present at the beginning and at the end of the sequence. So here we have 2 zeros and here we have 3 zeros. So let us define them separately. We'll store them in separate, you can say variables, or we'll name them separately. So Z mid will be the name of all those group of zeros that will require two wire cuts. So we have 7, 5 and 1. And these are the group lengths of zeros that will require two wire cuts. And the other we will store in side. So side means the beginning and the end. So that is why in this we will store those group of zeros which will require one wire cut. So they are 3 and 2. Now let us see how we can maximize the number of bulbs that we can keep off by cutting the wires. So here I have taken the same example. This is the state of the bulbs that we need to achieve. And we have already discussed about the group of bulbs that will be required that will require two wire cuts and the group of bulbs that will require one wire cut. So we have already stored the count in Z mid and side. Now we will always need to keep these two sorted in descending order. Descending order is that is from greatest to lowest. Why? Because here we are using the concept of maximizing the number of bulbs that we can keep off by cutting the wire. So maximizing means that we will always try to choose the maximum value out of these two, Z mid and side. We will always try to choose that group of zeros which consists of maximum bulbs. So it needs to be sorted in descending order. Now by intuition, you will always feel that since we are maximizing, so we will always select the maximum out of both these arrays. That is, we will select since 7, 5, 3, then 2 and then 1. So this will always be the order of selecting the bulbs. But is that true? So let us check with the help of an example. Suppose that k is equals to 7. That is the maximum number of wires that we are allowed to cut. Now we'll start selecting the group of zeros and also side by side we'll keep on reducing k for the number of wires that are cut because of selecting those group of zeros. So for Z mid we will reduce k by 2 and for side we will reduce k by 1 because Z mid is the group of bulbs that require two wire cuts and side is the group of bulbs that require just one wire cut. So now let us take one more variable g cuts. So g cuts will store the group of zeros that we can keep off by cutting the wire. So we'll store all those group of zeros here. Now suppose we select 7 from Z mid. So we selected 7 from Z mid and from k, which is initially 7, we will reduce k by 2. So 7 minus 2 is 5. So for selecting a group of 0 which contains 7 bulbs, we have reduced k by 2 because it is the group of bulbs that require 2 wire cuts. Now again, since we can reduce k by 2 further and it will not become 0. So that is why we will select from Z mid only the highest one, the next highest. So the next highest is 5. Again we will reduce k by 2. So 5 minus 2 is 3. Now we have already selected two groups, 7 and 5, that we can keep off by cutting the wire. Now k is 3. Now there will be two possibilities that we can select. So when k is 3, then the first possibility will be that we select one group from Z mid and one group from side. So if we select one group from Z mid, then we'll reduce k by 2, and if we select one group from side, then we will reduce k by 1. So 2 plus 1 is 3 and we'll make k 0. and that is what we want. We want to maximize the number of bulbs that we can keep off by cutting the wires. So that means that we should be able to cut all the wires that we can. The second possibility will be that we can select two groups from side. So if we select two groups from side, then we will reduce k by 2. Why 2? Because for each group we will reduce k by 1. So if we reduce k by 2, then still we will be left with 1. K equals to 1 will still be left, because 3 minus 2 is 1. So one wire cut will be wasted. But there can be a possible scenario when we need to do this, because the sum of these two wire cuts will be greater than selecting one from Z mid and one from side. So now here only let us check. Now we need to select one from Z mid and one from side. So we select one from Z mid. So we will select 1 because the next group in Z mid is 1. And from side we will select the maximum one because none has been selected from here. So it is 3. So we have selected 1 plus 3. Now if we select 2 from side. So if we are selecting 2 from side, then it is 3 and 2. Inside we have 3 and 2. So let us select 3 and 2 from side. Now we will check, is the sum of 3 plus 2 greater than 1 plus 3? So yes, 3 plus 2 is 5 and 3 plus 1 is 4 and 5 is greater than 4. So, and here we are maximizing the number of bulbs. So we will select 2 from side. So we will add 3 and 2 in G cut. That means these are the number of bulbs that we can keep off by cutting the wires. So let us quickly add these. What will be the answer? 7 plus 5, 12, and 12 plus 5 is 17. So these are the number of bulbs that we will be able to keep off by cutting the wire. Now what we need to really find in the question is that how many bulbs we can disconnect. How many bulbs we will need to disconnect in order to achieve this state. So what are the leftovers? The leftover bulb is only 1. So in this case, we will only need to disconnect just one bulb. So our answer will be 1. Because all other bulbs we will already be able to keep off by cutting the wires. Now one more thing that I'd like to bring to your notice is that this k equals to 3 case will always be true for all the odd values of k. If k is odd, then ultimately we will reach this state only. We will reach k equals to 3 at some point of time, because we will keep on selecting the maximum value from Z mid. Now let's take an example where k will be even. So let's take k equals to 6. Again we will do the same thing, that is we will count G cuts. So G cuts is the number of bulbs that we can keep off by cutting the wires. So we will first select from Z mid. So let us select from Z mid. Suppose we selected the maximum one, that is 7, and k will be reduced by 2. So k was initially 6 and it will reduce by 2. So k will become 4. Again we can select from Z mid. So we select 5 and k will again be reduced by 2, because and why it is reducing by 2 each time? Because we are selecting the 0 group from Z mid, which requires 2 wire cuts. So that is why k is each time reducing by 2. So here 4 minus 2 is 2. Now when k has reached 2, then we have two options, that either now we have two options when k is 2, that either we can select 1 0 group from Z mid directly, but it will not always ensure that we have maximized our G cut. So we will also have to check the possibility that we select these two from side. That means both these groups from side. and that is depending on the availability of these groups. So it can also be that these groups that are present on the beginning and end, either one may be available or both may not be available. So depending on that availability, we will select. But ideally, if both are present, then there will be two possibilities that we can select one from Z mid and two from side. So if we select one from Z mid here, then the sum will be 1 because only 1 is left here, as you can see, and k will be reduced by 2 because we are selecting from Z mid. And if we select 2 from side, then again k will be reduced by 2, 1 for each group of 0, and here we are selecting 2 from side, so 3 plus 2. So definitely 3 plus 2 is greater than 1, and we are maximizing the number of bulbs here, so we will select 2 from side. Let's select 3 and 2 from side. So again the answer will be like G cuts will be 17, and which is the leftover group of 0 that is left, so it is just 1. So we will need to disconnect only one bulb in this case also. Now even if suppose that only one 0 group was present in the side and not 2, then also these same two possibilities will be applicable, because then here what will happen, that it k equals to 1, so one wire cut will be left, but it will be useless because it cannot be applied in Z mid group, because here we know that we need 2 wire cuts always. So if we do not have 2 wire cuts available with us, then we cannot select a value from Z mid. And if suppose none of the 0 groups are present on the side, that is these two values do not exist, then we will have just one possibility, that is we will only be able to select one from Z mid. So all these possibilities can be generalized and can be covered. Now, broadly speaking, these are the two observations that we have made. That is for k equals to 3, or we can say when k is odd, and for k equals to 2, or we can also say that when k is even. Now if we try to combine these two observations, then what can be the generalized form of this? That when k is odd, then you can see from here that one element from side will always and always be selected necessarily, because from Z mid you are each time selecting one value and reducing k by 2. So in odd case, always one extra cut will be available with us. K is equals to 7, then we will always have 6 plus 1 cut. So for 6 cuts, we can choose from either Z mid or from side, whatever, but this 1 cut will be extra, and that we will always have to select from side only, because if we select from side, then only we can compensate for one wire cut. So even if there are no 0 groups present on the side, then this one wire cut will go to waste. So what we can do, if k is odd, then we will always select one from side, and k will be reduced to k minus 1. Then if k is reduced to k minus 1, then k has already become even. And for even case, you already know that when k is even, then and it becomes 2, then we will always have these two possibilities. So now here I would like to change this condition a little bit. When k is greater than equals to 2. Why greater than equals to 2? Because it can also be that from Z mid we have selected all the values that were present in Z mid, but k has still not become 2. K is still greater than 2. Then in that case also we will follow these two possibilities only. That is selecting one from Z mid or 2 from side. So now there are no values in Z mid, so we will not consider this possibility, but we will need to consider this possibility. So this is the generalized version of the observations that we have made. Now Based on these observations, we can easily derive the steps that we need in order to execute this question. So the first step will be that we'll divide the zero groups into Z, mid and side. So by now I hope that you all know what is Z, mid and what is side and how are we selecting that, how are we dividing the zero groups. Then the second step will be we'll check if k is odd. So if k is odd, then we will follow this flow. We will always take one zero group from the side and the maximum one, because as you know, these Z, mid and side will always be sorted in descending order, that is from greatest to lowest. So Z, mid and side is sorted, so we will always select the maximum value from side, and then k equals to k minus 1. So we will reduce k by 1 because we have selected one value from side which compensates for one wire cut. Now, after we have done that, we will move to this step only, which means that k is even. So this step will be followed when k is even. So here we have done k equals to k minus 1, making k even each time. Now in this step, when k is even, we will keep on selecting from Z, mid until k is greater than 2 or until the values in Z, mid are over, like we have reached the end of Z, mid. So until that we will keep on selecting the values from Z, mid, and also we will keep on reducing k by 2 because we are compensating for two wire cuts each time we are selecting a value from Z, mid. Then after that we will just check at last, after we come out of this area, we will just check at last that if k is greater than equals to 2, then what we'll do, we'll just have two possibilities. One can be that we can choose one value from Z, mid, or we can choose two values from side, and that will depend on which sum is greater. So if one value from Z, mid is greater than the sum of two values from side, then we will select this one, otherwise we will select this one. And these all the values that we are selecting, they are getting stored in the variable g cut. Now what is g cut? So g cuts is the group of zeros that group of bulbs that we are able to keep off by cutting the wires. So our answer will be, if we find out the total number of bulbs that are off in the final state that we need to achieve, so total minus g cuts, this will be our answer. So our answer is the minimum number of bulbs that we'll need to disconnect in order to reach our final state, and we can achieve that by subtracting g cuts from the total number of bulbs that are already off. Now let us quickly also discuss the input, output and constraints. So like always, the first line of input is the number of test cases. Then for each test case, we will be given n and k. N is the length of the state that we will need to achieve, state of bulbs, and k is the number of maximum wires that we can cut. And the second line of input will be a single string, that is S, which will be a sequence of zeros and ones, that is the on and off state of the bulb. Then for output, we need to print a single integer, that will be the smallest number of bulbs that we'll need to disconnect. And then the constraints. So the constraints here are like the number of test cases are maximum 1000, so it's fine. Then k and n can be up to 10 to the power 5. So basically for dividing the zero groups into Z, mid and into side, we'll require order of n time complexity, and then again we are just adding up the zero groups present in Z, mid and side until k becomes 0 or k becomes 2, I must say, according to our observations. So here you can see that k and n are both maximum 10 to the power 5. So our complexity will never increase beyond this, beyond order of n. Now one more thing, we were also performing sort, if you remember. Then we were also performing this sort condition on Z, mid and on side. So for this, we will require a time complexity of n log n. So our final time complexity will be n log n if we will do this sort. And the number of test cases are t, so we will multiply this time complexity by t, and there will be no problem. This time complexity will be easily acceptable for these constraints. Let us also keep a check on some of the boundary cases. So the first boundary case will be when we have our final state as 0, 0, 0, 0. That is, there is no switched on bulb present in the final state. So in this case, we will not need to disconnect any bulb, and straight away, whatever the value of k, we are not concerned with the value of k here because we do not need to cut any wire. So straight away our answer will be 0. So for that, we can just directly print 0. Then the second boundary case, or you can say a special case, is that if we have s equals to 1, 1, 1, 1, that means there are no off states. So in this case also, straight away our answer will be 0. We do not need to check the value of k here also because here we don't need to cut any wire. So straight away our answer will be 0. And there can be one more case, whatever the state may be, but if k is equals to 0, if k is 0, that means we cannot cut any wire. We will have to disconnect all the bulbs that we need to keep off. So suppose if the sequence is this, then here we have 4 bulbs that needs to be off in the final state. So our answer will be straight away 4. That means the total of all the bulbs that are off in the final state. So these are some of the special cases that we'll encounter. So now, after discussing all the steps, the boundary cases, and also the observations, it is time for us to discuss the code. I'll be coding in Python, guys. And just a heads up that you should always try the code first and then look into the video. Okay, guys, so now let us quickly do a walkthrough of the code. First, these are the inputs. So this is the number of test cases. Then we have run a loop for each test case. We will take the input as n and k and st. So n is the number of n is the number of bulbs, and k is the maximum wires that we can cut, and st, so it is the final state of the bulb. And then we will find out the solution, and we will also print our answer through this function. So I have passed all the values here, n, k and st. These are the important values that we will need in evaluating our solution. Now at any point of time, if you need to check the variables, then it is given on your right, and you can always go through the variable description if you do not understand it. Now let us get inside this function and see what have we done. So now first, as I discussed in the steps, that we need to find the 0 groups present in the final state. So first we will find the beginning and the ending 0 groups. Now there can be many ways by which you can find these 0 groups. So please try your approach rather than following what I have done here. But still, I'll explain you in short. So for finding the beginning and ending zeros, what I have done, that this is a for loop. It will keep on running until we encounter our first one that is present in the final state. As and when we encounter 1, then what will happen, that we will append that number inside, because that is 1 0 group that we have formed. And this I will be acting as the counter here, because I is the counter variable of the loop. So suppose we found 1 at the first position, then in that case I will be equals to 1. So that means 1 0 is present in the beginning. So if I is 0, that means no 0 is present in the beginning. In that case, we will not add anything in side array. But if it is not the case, then we will append or we will add this number inside. And then what we'll do, this is the substring. function that you have in other languages. So I have just removed that part of the 0 which was present in the beginning. Now, after removing that part of the 0, what I'll be left with, the first element will always be 1 in the final state. Now, I have reversed the string. Why I have reversed the string? Because now I need to calculate how many zeros are present at the end. So if I reverse, then those zeros will automatically come at the beginning. And again, I will just do the same thing with the reverse string that I just did above, because again I am calculating the 0 group. And again, I will, if it is present, then I will append it on the side. Then what I'll do, I'll again substring the string. So by doing substring again, what will happen that the zeros which were present at the end will also be removed from the string. So if those zeros which are present in the beginning and at the end, they are removed, then it will be very helpful for us to calculate the zero groups that are present in between, because we have to store them separately. Now, before we do that, this is one of the boundary conditions that I discussed with you, that if the length of our final state becomes 0, if after removing all those zeros, that is the beginning and the end zeros, if our length of the final state becomes 0, then it means that the string is of type which does not have any 1 present in it. So then in that case, we will directly print 0 and we will do return. So what will return do, that it will not execute the code present in this function further, and the next iteration will begin. Now, if this is not the case, then we will need to find all the 0 groups present in the middle. So now this is a very straightforward code that we will each time count the number of zeros, and when we encounter a 1, then in that case we will append this count, or we will add this count in our array, that is zmin. Now let us come to the main solution. So first what we'll need to do, first we will calculate the total, that is the sum of all the 0 groups that are present in the final state. So that will be, we'll do sum of zmit and sum of side, because we have already stored the 0 groups in these two arrays. Now, we will sort zmit and side in descending order. So here in Python, reverse equals to true will ensure that both our arrays, that is zmit and side, is sorted in descending order. Now, simply what we need to do is we need to find G cut, that is the number of bulbs that we will be able to keep off by cutting the wires. Before calculating G cuts, we can directly perform one more check, that is if k is equals to 0, meaning that we cannot cut any wire, then directly our answer will be total. So total was the sum of all the 0 groups that are present in the final state. So directly our answer will be total. But otherwise, if k is not equals to 0, then we will check if it is odd or even. So if it is odd, that means k modulus 2 not equals to 0 means that k is odd. In that case, we will reduce k by 1. And why are we doing this? That we have already discussed in the steps. Then what we'll do, that we'll check that if at least one element is present in the side array, that means the length of side array is not 0, then we will add this element in G cut. So if there is one element, then we will add it, and if there are two elements, then always, obviously, since the array is sorted, so the maximum element will get added to G cut. And while we doing this count side plus 1, so this is count side, it will keep a track of how many elements we have already added from the side array in G cut. So if we add one element, then we will increment its count by 1. Now we will, after doing this, our k has become even, and for all even k's, what we are required to do, we just need to keep on adding to G cut the elements present in zmit until k is greater than 2. or we reach the end of Z-mid. That means there are no more elements in Z-mid to add. So this loop does that. And as and when k becomes less than or equals to 2, then in that case we will break, means we'll come out of the loop. Now after coming out of the loop, we just need to check that if k is greater than equals to 2, then in that case what we'll do, that if I is less than length of Z-mid. So what does this mean? That means that if there are still some elements left in Z-mid, means the elements are not finished, there are still some elements left in Z-mid after this loop is run, then we will check the maximum. That is, we can select either one element from Z-mid or we can select the remaining elements from side. So we are checking that the sum of elements present in Z-mid, that is the only one element, or the sum of elements present in side. And why have we done this count side? Why have we used this here? Because if initially we had already added one element from side in G-cut, then we will not do that again. So we will only add those elements which are not already added in G-cut. So for that we will check, and the maximum one will be added to G-cut. Else, if there are no elements present in Z-mid, then simply we will add all the elements that are present in side. And then finally our answer will be total minus G-cut. So the total number of bulbs that were off, and G-cut is the maximum number of bulbs that we can keep off by cutting the wire. So guys, this is the code. Now I hope that you will be also able to code this problem on your own. If you enjoyed the video, then please like it, and also if there is any feedback or any suggestions, then please post it in the comment section below. And don't forget to subscribe to the live classes that will be given by the top coders of the world. You can use my referral code, which is given in the description box below.